Hello guys, how are you? Welcome back. In this video we're going to look at the turning effect of force, right? And these are the specific objectives from our syllabus that we need to cover by the end of this topic. Yeah, so let's jump right in. Turning effect of force. Moment of a force is a measure of the turning effect of force. It depends on the magnitude of the force applied and its perpendicular distance from the pivot. Moment is equal to force times perpendicular distance from the pivot. Mathematically, this is how we represent it, where M is moment, F is the force in Newton, S is the perpendicular distance from the pivot, can be in centimeters, meters, or millimeters, right? The units are Newton meters, Newton centimeter, or Newton millimeter. A good example of turning effect of a force is when you open or close the door at home, right? The pivot where the turning occurs is the hinge of your door. From this example, you can see that moment is a vector quantity. It has direction and signs. And also, we know that when we want to open the door or close it, it is much simpler when you push it far from the hinge or maybe around the area of where the lock is usually placed. So it makes it makes it easy for you. The force that you apply will be small, right? So let us look at the examples so that we know what a pivot is and the perpendicular distance we are talking about. So here are two examples. So this is where the force is being applied, right? This is where the force is being applied by this boy, and this is the what? This is the load. This is the load, and the pivot is here. This is where the pivot is, here around the axle. This is where the turning occurs, and in this example, this is the pivot because the turning occurs here, and this is the what? The force that is being applied. This is the force that is being applied. There is only one force here, but here we have two forces acting. The load, which is the weight of whatever is in the wheelbarrow, and then the force applied by this man here. So we have two forces. You can say F1, then F2, where F2 is the what? Is the weight, the load. Alright, I just wanted to clarify the pivot. So this is the pivot, this is the pivot where the turning occurs. So now let's make a few calculations involving moments. Here is an example. A uniform bar of length 1 meter is acted upon by different forces. Determine the moment caused by each force. How many forces do we have? We have this force. Let's call it F1 and call this one F2. Right? Then we know that moment is equal to F times S. Moment is equal to force times perpendicular distance. Distance, right? So let's start with F1. We'll call it moment 1 because it is due to F1, right? So this is M1 is equal to F1 times S1, right? So we are going to look for F1. So this is F1. This is F1, this is the pivot. So the distance from the pivot to F1 is S1, right? That's the distance. So, but what distance is that? Let me write the force first. 10 Newton times what is S1? This is a uniform bar of length 1 meter. So this is 0.7. So if this is 0.7, we are left with how many meters to make 1 meter? I mean, what length is left, which when added to this one will make 1 meter? That's 0.3, because 1.1 minus 0.7 is equal to 0.3. So this is 0.3. So let's multiply this, we get 3. That's 3, right? So M1 is equal to 3 Newton meter. So this is M1, moment due to F1, right? And then let's look at M2. F2 times S2, just to distinguish the two. So F2 is 5. How far is it from the pivot? Here is the force, I see it. Here is the pivot. So I'm looking for this length. The good thing is it is already clearly shown that is 0.7. It's 0.7. If we compute this, we get 3.5 Newton meter, right? B, let's look at B. We have two forces, so this is the same bar, right? Now we have different forces at different positions, so the whole length of this bar is 1 meter, right? So let's call this F1, F2, and the distance from the pivot to F1 is S1. The distance from the pivot to F2 is S2. Right, let's start with M1 is equal to 12 Newton times, what is the value of S1? This is 0.4 to get here. What is left to make 1 meter? 0.6, right? 0.6 meters. This time around, I have included units so that we see what happens with units, right? So 12 multiplied by 0.6 is 7.2, and the units are going to come out this way. It's not like you just have to memorize the units, you get them from the quantities that you will be using, right? So this is M1. How about M2? M2 is F2S2. So M2 is equal to F2 is 4 times the distance of 4 Newton force from the pivot is at the other end, and the pivot is at the other end, and this is a 1 meter bar. That means it's 1 meter, right? It's 1 meter. you get 4. And 2 is 4. So the final answer is 4 Newton meter. Now let's look at question number 2. The diagram below shows a 2 meter uniform bar of mass 2 kg hung by a string at one end. Okay. Use equation of moments to find the weight of the bar, that is given that its moment is 25 Newton meter. Use W is equal to mg to confirm your answer, right? Okay, we have to confirm our answer by using this formula, right? So moment is equal to force times distance, and is given as 25 Newton meter, right? We are to find the weight. What do we know? What do we know? It's a uniform bar, right? So the weight acts at the midpoint. So that means from here to here we have 1 meter, because this is the center. The other side is also 1 meter, right? Good. So what do we do? M is equal to Fs, and weight. So here we put the value 25 because it's already known. Here what we know is if we multiply weight times 1 meter, we get 25. So what do? We divide both sides by 1, both sides by 1. Therefore, weight is equal to 25 Newton. To confirm that, weight is equal to mg, mass is 2.5 times 10, g is 10, right? It's 2.5, this is 25 Newton. Confirmed, which means this is correct, right? Let's look at part B. If the tension on the strain is 20 Newton and it creates a moment of 25 Newton meter, determine length D on the above diagram. Okay, good. Moment is equal to force times distance. But first of all, let me do this. So this is my pivot, this is my strain, right? This is where the tension is. And to find D, I first have to determine this distance. This distance, call it S. Then here we have our force, of course. This force is same as the tension on the strain. So M is equal to Fs. What do we have? We have the moment is 25. We also have the length the force we are given as 20. The moment is 25. So we are to determine this S first before we can find the D. Because why? Because we know the total. We know that S plus D is equal to 2 meters, because it's given here. It's 2 meter bar, right? And then what's next? We divide by 20 both sides. Into 21 to 21, then 20 into 21 to 25, 1.25. That means S is equal to 1.25 meters. So what do? S plus D is equal to 2. So 1.25 plus D is equal to 2. So if we subtract, if we take this to the other side, what do? What number that which when we multiply, we add to 1.25, we get 2. That's 0.75. That's 0.75. And if we want to show that, we just do it this way. 2 minus 1.25 is equal to D. This is equal to 0.75. Right? So D is equal to this. So D is equal to 0. Let me write it here. D is equal to 0.75 meters. So this is the answer. Right? Thank you. So the next video we are going to look at the principle of moments.